In this video, we're going to look at drawing cubic, reciprocal and exponential graphs from a table of values. Let's start off with a cubic graph. We're asked to draw the graph of y is equal to x cubed plus x squared minus 2x plus 4 for x between negative and positive 3. We can see this is a cubic equation as the highest power of x we have is x to the third power, or x cubed. If we just had y is equal to x squared minus 2x plus 4, that would be a quadratic graph. If we just had y is equal to minus 2x plus 4, that would be a linear graph, or a straight line. If we just had y is equal to 4, that would be a horizontal line across the page where y is equal to 4. So we can automatically say now this is a cubic equation, and we can go ahead and do this. What I like to do here is just put up my table of values. I put the x coordinate and the corresponding y coordinate below. So we're going to have our x coordinates just here and our corresponding y coordinates here. So we're starting at negative 3, negative 2, negative 1, 0, 1, 2 and 3. If this is a calculator question, you can simply go and set this up. So for example now, all I'm going to do here is press my brackets, then I'm going to cube the bracket. Then I'm going to add one lot of x squared. Then I'm going to subtract two lots now of just x, and then I'm going to add 4. So this is the equation I've got right here, and I can simply substitute values in. So I can now put negative 3, so negative 3 goes in here, and then we'll have negative 3. Then we'll substitute in now negative 3 just here, and this will give us the first value, which is going to be negative 8. So writing in my table just here, when x is equal to negative 3, y is equal to negative 8. You might have to show full workings. So for example, if I was to show full workings, we'd have now negative 3, which I need to cube, plus now negative 3, which I need to square. We're going to subtract away two lots of negative 3, and we're going to add 4. If I now just put that as a cubed, if I cube negative 3, that's going to give me negative 27. 3 to the power 3 is 27. If we've got an odd power and a negative, it's going to be negative. This is negative 3 times by negative 3, which is positive 9, and then we're multiplying by negative 3 again. This is going to be squared. When we square a negative number, it's going to be positive, so this is going to be plus 9. I'm now subtracting two lots of negative 3, which becomes plus, and then I'm going to add the 4. So this is going to give me minus 27 plus the 19, which is going to give me now that value of negative 8 that we just found. So do check the level of working that's expected. I'm going to continue with the calculator and just flip these over. So changing these over now, we're going to have in here the 2, and then we will have on here now, instead of negative 3, we've got negative 2. So that's going to give me positive 4. So we can put down here positive 4. We're now going to swap this over now to negative 1. So negative 1, just popping these in, negative 1 in here, negative 1 in here, and then finally the next one. So in they go, that's going to give me now positive 6. With 0, I'm not going to substitute this in, because this one would be 0 or 0, this would be 0, this would be 0, and we would just be left now with the 4. So when x is 0, we can say y is going to be equal to 4. 0 cubed, 0 squared, two lots of 0, it's always going to be 0. So that one's nice and easy. From here, all I'm going to do now is for 1, and we're going to swap these over. We won't necessarily get the same value here if we have 1 and negative 1. Don't fall into a trap. Just put the numbers in. That's going to give me now positive 4, which is just here. So all I've done now is subbed in 1. So 1 cubed, we're going to have on here 1 cubed, then we're going to have 1 squared. So that's 1 plus 1 minus 2 plus the 4 is going to give me the 4. Don't worry that these two are the same. Let's go ahead now and put in positive 2. So if we put in positive 2, let's do that. Positive 2, and we will get our next value. That's going to give me positive 12. So we'll put in here positive 12. And then finally, we will put in now positive 3. So just switching these over, let's go to 3. So that becomes 3, and then this one becomes 3. So when we do that, that's going to give me 34, positive 34. So let's go ahead now and look at plotting these points. So starting from left to right, we're going to have -3 on the x-axis, -8 on the y-axis. So if we look at that down here, -3, -8 looks to be about there, and I'm going to plot that point. If we now look at this one, -4, +2, well, x is -4, and then we've got now on here x is -2, y is +4, so x is -2, y is +4, which looks to be just there. We've then got -1, +6, so -1 is just here, +6 is just here. We've then got the next one, which is going to be 0, 4, which is going to be just here, so x is 0. We've got y is equal to 4. We then have now the next one, which is 1, 4, which is going to be just here. So we're going to have 1, 4, which will be there. Then we have 2, 12 and 3, 34. So 2, 12, which is going to be just there. And then we have 3, 34, which is going to be just here. At this stage, we now need to draw a sweeping curve through these points. This is not a collection of straight lines, it's a curve. Anytime we have anything other than x here, we're going to end up now with a curve. So when we have a quadratic, a parabola, x squared, we have now a sweeping curve. The same goes with a cubic. So what I'm going to do is come through these points like so. This is not going to be a straight line, and I'll show you that by substituting in x is equal to 1/2. So if we do that, let's go ahead now and swap this over to 0.5. We will see that that is going to give us a lower value. So if I just change this, just to show that's not going to be a straight line across, it would be tempting to do that, but let's just show that that's not going to be the case. And we end up now with 3.375. So we could see that that is going to be somewhere just here. So it's going to go round like so. When I connect these up, this is not going to be hugely accurate because drawing on the tablet is quite hard, but this should be a nice sweeping curve. The more of these you do, the better you'll become at them. So we'll come round to this point right here. We will come through like so, through this point here. We will come down, we'll come round like so, then we'll come up to this one just here. Looks something like that, give or take, and then we'll come up to this point right here. So let's make that look nice, a nice sweeping curve, and we'll just connect them up and it will do something like that. So that's not brilliant, but we get some idea. Of course, this is going to continue down here like so, but we're only asked to draw it from negative to +3. So if we have this now, we could simply write that this is y is equal to x cubed, or x to the power 3, plus x squared, minus 2 lots of x plus 4. And that is the graph, and we've done that. So that's a positive cubic equation. We can see that it starts now at the bottom left, or what we call the third quadrant, and it finishes or goes out in the first quadrant, or top right. If this was negative, it would go the other way. So if you have a negative x cubed, that will go down, something like so. So I'll just quickly hand sketch an example of a negative cubic. We might have something that looks like that. So just coming down here, that's an example of a negative cubic graph. Okay, so that's that one done. Let's move on now, and we're going to look at what we call a reciprocal graph. We're asked to draw the graph of y is equal to 1 over x for x between negative and +5, where x cannot be equal to 0, writing down the equations of the asymptotes. Okay, let's just take stock here and look at some of this information. This is 1 over x. We're going to take values from negative to +5. We can't include 0 as it's undefined. 1 divided by 0 is undefined. If you think about how many naught cubes can you get in a cube of size 1, the answer is infinitely many. So if we do it now, it will give us an error. 1 divided by 0 is undefined. So it's math error. So we just need to exclude that on there. We will consider these asymptotes shortly. Let's go ahead though and get a table of values. So what I'm going to have now are the corresponding y coordinates when I substitute in now the x. So we'll have x and we'll have y. We're starting at -5, we're going to -4, -3, -2, we're going to have negative 1. 0 is not going to give us a value, so we're not going to have that. Then we're going to have 1, we're going to have 2, 3, 4, and 5. If you want, what you can do is write undefined. Here, again, it's entirely up to you, but we're told that x is not equal to 0. Let's go ahead and do that. Now, if we look at this, we've got 1 over negative 5, which is going to give us negative 1/5, or if you like, negative 0.2. This one is going to give us negative 1 over 4. We're simply substituting in these values. This is going to give us negative 1 over 3, negative 1 over 2, or if you like, negative half. This is going to give us negative 1. If we look the other side, we're going to get exactly the same values, but we're going to end up with the positives. So we're going to have 1, we're going to have 1/2, we're going to have 1/3, we're going to have 1/4, and we're going to have 1/5. Essentially what's happening here, as we're increasing the magnitude or the size of x, y is going to do what we say, tend to 0. So it's going to get incredibly small each time we increase the x coordinate. So for example, if we had 1 over 100, that would be very close to the x-axis. That's where we're going to bring in this idea of the asymptote shortly. So let's go ahead now and look at plotting this. So what we've got, and we'll start now to the right of the coordinate axis, we've got the point 1, 1. Now 1, 1 is going to be just here. We've then got 2, 1/2. 2, 1/2 is going to be there. We've got 3, 1/3, which is going to be about, give or take, just there. Then we're going to have 1/4. 1/4 looks to be about there. We're going to have now on the next one 1/5. If we look now to the negative side, or to the left of the y-axis, we're going to end up now with negative 1. So we're going to have this point right here. So 1, negative 1. We're going to have negative 2, then we'll have negative 1/2. We'll have negative 3, and we've got negative now 1/3. So let's put on a third. A third is going to be about there. Then we've got now negative 1/4, which is going to be about there. And then we're going to have now negative 0.2. So what we end up with now, and we're going to just draw this, and I'm going to actually extend this shortly and draw a better sketch of this below to look at some of the key features. So we can see now that it's going to be symmetric, and let's just do these parts right here. What I'm not doing is now looking at values less than 1, so from 0 to 1, or if you like, from negative 1 to 1. Just because we didn't plot 0 doesn't mean that they're not important. They are hugely important. So let's come down here, and it'll look something like that. Now, if I were to extend this, what we'd end up with is something looking like so. And with this one, what we'd end up with is something looking like so. So it'd do something like that. What I'm going to draw below now is the actual graph if I did a sketch. So what we're doing is a plot. We're going to look now at a sketch of the graph of y is equal to 1 over x. So what we're going to have now, to the right of the y-axis, it's going to look something like so. It will come round, and then it will gradually get closer and closer to 0. If we look now the other way, let's come round, it will do something like that. Okay. We can now consider, I mean, that's not very accurate. We should be, let's just make that look a little neater. This is going to be tending now to 0. It's going to, the absolute value is going to get smaller and smaller. Okay, let's just think about this now. What we have are things called asymptotes. Asymptotes now are equations of lines here, and in this particular case, we've got now the x-axis and the y-axis. The asymptotes now are going to be y is equal to 0 and x is going to be equal to 0. We can't have 1 over 0, and also this function, so if we call the function y is equal to the f of x, where the f of x is 1 over x, it can never be 0. So if you think about now taking a bar of chocolate and cutting it in half each day, if you cut it in half and cut it in half, It's going to get smaller and smaller, but it will never ever disappear. And that's why we have these asymptotes. So even if I had 1 over 10 billion trillion million thousand whatever, it's still not going to be naught. We can't get rid of it, and that's what this asymptote says. It tells me that it can never be equal to 0. And by the same token, we can never have on here the point x is naught, because we can't divide by 0. So therefore, it's undefined. If we just think about this now, let's look at values less than 1. So from 0 to 1. If we look at these values here from 0 to 1. So if I think about it, if I took now 1/2. So when x is equal to 1/2, what we're going to have then is y is going to be equal to 1 over 1/2. 1 over 1/2 is going to give me 2. So we can see now that this point right here, remember this point here is 1, 1. So what we're going to have is 1/2 here, 2. If I took x is equal to 1/4, which is even smaller, it's closer to 0, y is going to be equal to 1 over 1/4, and y is going to be equal to 4. So we can see now that it's grown. So this point right here is going to be 1 over 4, comma 4. It's going to get bigger. So if you think about this, if it's 1/10, it's going to be 10. If x is 1/100th, it's going to be 100. If x is 1000, it's going to be now, or 1/1000, let's just put these on, let's just put these in. We can see that that would give us 10. This now would give us, if I put in 1 over 100, that would give us 100. This would give us now 1 over 1/1000, which is going to give us 1000. So you can see as this now gets very close to the y-axis, that is going to get huge. And in the same way, it will get hugely negative in this direction. And that's why we draw it like so. So that's what we've got, and that is a rough sketch, and this is plotting the values. Okay, so write down the equations of the asymptotes. We have two. X is naught and y is naught. Right, let's look now at an exponential graph. We're asked to draw the graph of y is equal to 2 to the power of x, for x between negative and positive 5, writing down the equation of the asymptote. So let's go ahead now and look at a table of values. So with all of these examples, we're not sketching, we're simply looking at a table of values. So what we're going to have here now is x, and we're going to have y. So if we start now on here with -5 and take this up, -4, -3, -2, -1, 0, 1, 2, 3, 4 and 5. This is 2 to the power. What I'm going to do is start it just here. 2 to the power of 1, when x is 1, is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. Anything to the 0 power when we have this value, and we're talking, this is a graph y is equal to a to the power of x, where a is a positive constant on here. So it's a positive value. Anytime we have y is equal to a to the x and x is naught, that's going to give us 1. If we look at this now, what this is saying is y is equal to 2 to the power of -1. If we go back to the rules of indices, this is going to be 1 over 2 to the power of +1. So this is going to give us now 1/2. If we look at this one, this is 2 to the power of -2, which is going to give us 1 over 2 to the power of 2, which is 1/4. If you're unsure, you can use a calculator. So what we've got now is the following. We've got on here the value right here, so let's go ahead and do that. We've got now 2 to the power of -2. So 2 to the power of -2 is going to give us 1/4. Just remember with the rules of indices, let's write these down. The rules of indices, a to the -m is equal to 1 over a to the +m. So if I said, for example, 2 to the power of -3, that is 1 over 2 to the power of +3, which is going to give us 1 over 8. So we can go ahead and just put these in. So that's the one we're doing now. This is going to be 1 over 8, 1 over 16, and we're going to have 1 over 32. we can see clearly as x gets very negative, so it goes in the left, we can see this value is getting tiny. As we go to the right, we can see it's going to end up being huge. What I'm going to do is plot values from 0 onwards. So if we take 0, 2 to the 0 is 1, which is just here. So that's 2 to the 0. 2 to the power of 1 is going to give me 2. 2 to the power of 2 is going to give me 4. 2 to the power of 3 is going to give me 8. And we're going to see this start to really take off. This is going to get very big very quickly. The higher the value of a, so this in this case 2, if we put 3, it's going to be even steeper. 4 is going to be even steeper. So if we now put this on, that's going to be just enough room, just fair, and that's going to be on here. Now if we look to the other side, what we're going to have is -1 is a half. We're going to have now, so that should be just there, shouldn't it? -1 is a half. I change the scale. Do check that the scale is there, or correct, rather than making that mistake. 2 to the -2, we can see that these are just going to end up now tending to 0. They're going to get smaller and smaller. So our curve, again, this is only as accurate as my hand is on the tablet, which is never brilliant. What we have is the curve coming up like so, through these points, and let's just make that there we go. So again, this is not a collection of straight lines. This is a sweeping curve, and we call this an exponential curve. We model growth and decay with these curves, so it'll look something like so. And then we're going to come here, and it's going to, this is going to be a bit, that should be closer. Hopefully I can get some, right, let's do something like that. So this really should be closer to the x-axis. As you can hopefully see, it tends to 0, so we should be down below those. What I'm now going to do is put the asymptote on here. Remember, this can never equal 0. So what we can say then is that the equation of the asymptote here is that y is going to be equal to 0. And that is the asymptote. So it's never going to be 0. Even if we had 2 to the power of -1 trillion billion whatever, it's still going to be now greater than 0. So we can say all of these values are going to be greater than 0. Let's just have a look at another one. This is a growth model. When we have the value now of a, which is just here, greater than 1, so when we go greater than 1, we're going to have a growth model. If we have anything from 0 to 1, excluding those, we're going to have something that decays. Now, if we think about this, let's look at y is equal to 1/2 to the x. So 1/2 to the power of x. If we consider when x is equal to 1, we're going to get y is going to be equal to now 1/2. When x is equal to 2, that's going to be a half squared, which is going to be 1/4. So we can see in this case, it's going to get smaller. If we went the other way and we said that x was equal to -1, this would now be, and you can look at this a couple of different ways, this would be 1/1/2, or we could go ahead and write this, and I'll show you a couple of different ways of doing this. So we could write it like so, which means what we would do here is right now, we could flip this and write this as 2/1 to the positive 1 power. Or what we could do is write this, if your algebra skills or rules of indices skills are really good, 1/2 is 2 to the power of -1 raised to the power of x, which is going to give us now y is equal to 2 to the power of -x. This particular example here gives us a graph transformation. This now is f of -x, which is a reflection in the y-axis. So hopefully you can see, and I really will sketch this is going to be a freehand job. It will be symmetric to this, but we'll have now the decaying function instead of the growth one. It will still come through this point here, but this time now 1/2 to the x will stay obviously above that line, but that's what we end up getting. So if we just draw a few sketches, let's go ahead and draw these below. All of these exponential graphs, unless transformed in some particular way, will pass through the point 0, 1. So what we've just drawn now is y is equal to 2 to the x, and it'll look something like that, and we'll come up and we'll get very steep very quickly. So we saw 2 to the power 5, that was 32. 2 to the power 6 is 64, to the power 7, 1 to 8, 8 is 256. 9 is 512, and you can see it's going to get massive. It will come through this point here, 0, 1, and now y equals 0 will be the asymptote. So this is y is equal to 2 to the power of x. If we now look, what we'll have, and I'll draw another one, we're going to have a graph, and this one is going to be looking something like this. So let's go ahead, that's going to come through, and this one, same point, 0, 1, this would be y is equal to 3 to the x. So y is equal to 3 to the power of x. So if we picked a point on this one right here, what we'd have is 1, 3. And if we picked a point on this one here, now we'd have 1, 2. So we can see for positive values, this is going to be steeper and above it. Yet here, now let's pick this point right here. On this one, let's say this is -1. This is going to be -1, 1/2. Yet this one right here, what we're going to have now is -1, and then we're going to have 1/3. So we can see it's lower for negative values. So that's just an example. Let's go ahead now and do a different one. Let's put on this one. I'm going to put, now that this, and coming through this point right here, we can see that's even steeper. This one is going to be now y is equal to 1/5 to the power of x. So these are just some sketches of some other particular exponential functions, so growth and decay models. So there we go, drawing 3 different graphs. We've looked at a cubic, we've looked at a reciprocal, and we've looked at an exponential graph. There is a difference between plotting and sketching. Sketching is freehand, considering the main shape and the points of intersection of the coordinate axis. When we're drawing or plotting, we're doing a table of values and then going ahead and connecting the points up. So do check what you're being asked. The further you go in with your studies, it's more likely that you're going to be asked to sketch, and a table of values is not the general way that you would carry out a sketch.